Hi everyone, welcome back to my YouTube channel. So in this video, we will talk about the common scenarios or the common test cases related to the fact and the dimension table. Okay, so let's get started. So generally we see the customer data is in the raw format, right? And from that raw format, we generally do some ETL, do some kind of transformation and all, and make the data more logical form. Okay, try to make it in a more logical form. And after that, we will create the data model. Okay, so when I say we will create the data model, it means I will be creating few tables, and these tables are in the form of fact and dimension tables, basically. Okay. So the question here is why we need these fact tables and dimension table. Okay, so when I say data modeling is all around the fact and the dimension tables, it actually helps you to efficiently basically efficiently querying the data from the table out. Okay, from these tables. And it will also help you to understand what is the relationship between these two, the fact and the dimension tables, okay, or the different tables among your schema or the model, okay. It will also help you to scale it up if required, right? If you keep everything in a single table, obviously it is really tough to scale it up and store the data in it, right? But if you keep your data in a proper model, okay, you can actually scale your data at any point of time. Okay, that will help you. Now you can maintain the data quality in it, right? Your data will be in a proper quality as well. You can analyze your data, right? So when I say analyze, you can actually find few solutions of your problem. Okay, so let's move ahead with the next slides and try to understand what kind of problems generally customer face and what kind of solutions he can get with the data model. Okay, or the fact and the dimension tables. Okay, so let's talk about the problem statements first. So the first problem is, let's say you are a selling firm and you wanted to know what are your top selling products. Okay, the second question could be, what is your sale trends? How the sales look like from last 3 years or from last 3 months or from last 1 month? Then what is the customer preference? Which products customer basically looking for? What would be your pricing strategy? Right? With what price customer is comfortable for buying this product? So these kind of questions generally you have if you are in a sales or if you are selling few items or any fresh product or anything, right? These kind of problems generally a customer face. I'm just giving an example, right? There could be many. So to get a solution from these problems, okay, to get some solutions out of it, why data modeling is needed, just take an example. Just try to understand with this example. So let's say you are basically having a store, okay, and you are selling the most focus, and basically you are selling some good items, okay. In basically you're selling the food items, okay, sorry. So when I'm saying the top selling product, it means the store or the store owner wants to identify what are their products which are the most in the demand and the most focused, okay, so that he can so that he can stock those products to meet customer demands. Okay, for example, if they find the fresh products sales higher than their packaged goods sales, right? So they will increase the fresh product inventory. That's how things works, right? So these kind of questions can be answered with the data model, right? When I say sales trend, okay, so this sales data, they will generally use this information to plan their inventory and marketing strategy, right? So based on their sales trend, right, how much sales they are giving, okay, or the firm is making, based on that they can maintain their inventory and do some marketing strategies. For example, if they notice the spike in the sales of meat product around the holidays, they can plan the stock up and meat products and run targeted marketing. Okay, because you know, in the weekends, there will be a lot of demand for the meat product. Same, the next question, the customer preference, right? So they can analyze what generally customers are looking for, right? And for example, if they notice that their customer basically prefer the organic foods, right? They will increase the organic product offerings. Simple. The next one is pricing strategies, okay? Now, they can use their data to optimize their pricing strategies. Like how? For example, if they find that the certain products are not selling well at their current pricing point, they can adjust the pricing to attract more customers, right? And that's how these problems will be sorted out, right? Now, let's take a look without wasting much time, like how data models generally look like. And I'm taking, so here I took an example of star schema data model. Okay, so if you see it has the edges, right? And why this is called as star, because these edges are nothing but the dimensions. Okay, see, these edges are dimensions. Basically, you can have more dimensions if you want, that's okay, but the major part will be in the middle. Okay, and based on these dimensions, the fact table will be driven, right? So it shows the relationship. Okay, if you see here, it is showing the relationship. Here the product ID is basically the foreign key in the sales table, right? Same for the customer ID, same for the store ID, same for the date ID, right? So you can see the relationship among them, okay? And it will be very easy for the customer as well to understand how their data looks like, okay? Now, based on these dimensions, they can actually query the results, okay? So, as I was keep on saying, like, why we are keeping in the star schema, what are the benefits of data model? So here it is. The major benefit is the performance, okay? When I say performance, you can keep your data in a single table as well. But if you keep your data into the modeling way, right? If you are properly modeling your data, right? Basically, it is very easy, or it will be very optimized for querying and analysis, okay? Then the data integrity. When I say data integrity, okay, so data tables or these dimension tables or fact tables are designed to ensure the data is consistent and accurate. Each table has its own primary key and foreign key relationship, which will help to maintain data integrity and reduce the risk of errors or inconsistencies amongst the data. When I say flexibility, okay, so flexibility means it is easy to add or modify the data into the table, right? Correct. Over a business periods or over a business evolve, right? This allow us to adjust the data model to better reflect the changes, right? Because your data will keep on adding here in the fact table, but the major dimensions will be keep on adding there as well. So now you know that for this customer, earlier you have only 10 records, but he is now more involved in your business, and he's kind of buying most of the products from your store only, right? So this kind of flexibility is getting, this kind of information you are getting because you have the flexibility to store more and more data, right? And again, since you are getting the data, it will be easy to query and everything. So obviously it will help you to analyze your sales and other aspects as well. Okay, so this is the reason why we keep data into the data modeling. Now, when I say the fact and the dimension table, as I was saying, that in the star schema, the dimensions are nothing but the edges, okay, and the fact table resides in between inside, right? So it is fine with the diagram that this is the difference, right? But what is the actual difference? What kind of data lays into the dimension tables and the fact tables? Let's try to understand that. So first we'll talk about the fact table. So if you see here, the fact table contains the measures, the numeric values that we wanted to analyze. When I say measures means some calculated columns, right? So let's say a company wanted to see the aggregate data or something, right? So it will create some measures out of it, right? And it will create one more fact table. It's up to you. It's up to the customer requirement, right? But just for the understanding, you can understand it as a calculated columns. And believe me, we need to verify it. Okay, it's a topmost priority when we do testing. Now, the second thing is usually the fact table contains the information related to the transaction, event, and occurrence, right? So when I say event and occurrence, it means one customer, right, is doing a purchase or he did purchase 3 times in a day, right? So these calls the event, right? So each transactions will be stored inside the fact table. The customer data is already in the dimension, right? The product is already in the product table, but the transactions will be stored into the fact table. That's the difference between fact table and the dimension table. So since you can see for a single customer or for a single product, there could be multiple transactions, right? Obviously, the data into the fact table will have large number of rows as compared to the column. Then the fact tables joins with the dimension table to provide context and descriptive information. You see in the fact table, you have this transaction, but you wanted to get a detail out of it, right? So you can have a join and you can get a context out of it, right? When this event happened, this customer buys this product, right? Right? So what is this product? When it was available? What was the price of it? So if you wanted to those informations as well, you can get it. So fact tables actually helps you to create a join among these tables and get a more insight of the data. When I say dimension tables, it contains some descriptive information about the attribute. When I say attribute, again, we are talking about the customer, right? Now this customer you have a phone number of the customer. You have name of the customer. You have address of the customer, right? So these kind of details you can get. So these are called attributes, okay, related to the transaction or the event, right? Such as the product, store, customer data, and dates. Now, what else? Dimension tables has smaller number, as I was saying, right? Because it doesn't contains the transaction. Once the customer data is stored, it is stored. You don't have to be store it again and again. Otherwise, it will be repeated data. It actually helps you to provide a measure, okay, into the fact table. So when you create your measures, these dimensions tables will also be used. Provides a way to slice and dice the data such as a product, store, that customer and date, right? So you wanted to see the trend, right? The last 2 years trends, right? So the date will be pulled from the date schema or the date dimension model, and the data will be pulled from the fact. And you can and you can see the data, you can see the trend based on the date. So these dimensions will actually help you to provide the slice and dice data, right? That's how it works. So now I hope this is clear now. What is the difference between the fact table and dimension table? Why we need the fact table and dimension table? Why we need the model, right? What kind of benefits it will give to the customer and everything, right? So let's quickly see what kind of sample test or scenarios we generally do with the fact tables. Okay, so the first one is test the sales ID is a unique, if it is unique or not for each transactions. Just give me 1 minute. Let me pull that information as well here so that it will be easy for you guys to correlate it. Okay, just give me. Yeah, sorry. The image is somehow missed. That's why I just copied that table image and kept it over here. Okay. So my test was, what I was talking here is that I want to verify if the sales ID is unique or not. Okay. So this is the sales ID column. So first of all, I will check if this ID is unique or not, right? Because for every transaction, there should be a unique number out of it. Okay. Now, test the product ID exists in the product dimension tables. So if there is any product, any store, any customer, any date, right? Any dimension information or the foreign key is available in your fact table, it should be present into the dimension table as well. Okay, so this data should match with the dimension table. Same is written among these test cases. Okay, apart from this, you need to verify the sales amount is a positive value, right? I mean, I have just written it as in a hypothetical test case or a simple test case like the positive value, but in your case, you should verify the sales amount, okay? The sales value, right? The sale value for each transactions from the source data. And you should verify between source and this target that the data should match. Okay, so you have to do here source to target matching. Okay, now you see, other than that, you can verify if the data has a high level, like the data should be a positive data, the data should not contain null or empty records, the data should be corrected, correctly calculated. Okay, it was wrongly written. Okay, so these kind of because I have only one transactional data here, I can say, or the column which stored the data, right, majorly. So that's why my test cases are mostly focused for this particular column. But in your case, you will be having 100 or I'm sorry, basically you will be having more than 20 or 30 columns. It could be, okay, or more than that. It again depends, right? So you need to verify all those columns, but generally it is not more than 30 or 20, right? So apart from this, you need to verify the schema if it is matching with the defined standard. Okay, if it is an integer, it should be integer. If it is a float, it should be float, like that way. Okay, the test calculated column values based on the business logic and the aggregates, right? So if you are creating more columns, and this is depends on the aggregated value, right? So that value should match, okay, based on the business logic. You also need to check the incremental data load. Okay, as I was covering in my another video, right? What is incremental data? So you need to verify those information as well, like the last loaded date, is it a latest record or not, right? So these kind of informations you need to verify as well. Okay, if you wanted to understand more on this, you can watch my another video which is related to the incremental test cases. Okay, but as in fact and dimension, you need to verify each and every column. You need to verify their existence. You need to verify the data out of it. Okay, as in general terms. And then the count, obviously the count and the data, these two things are important. Now, when we talk about the dimension table, it's again same thing. Like the primary key should be always unique. It should not be having the duplicates. It should not be the null, right? The category is a valid category. Like when we say we are storing the electronics and cloth things, right? The category should include only these things. It should not include the foods and the beverages, right? So these kind of information you need to verify. The price should always be a positive value. You should not see any minus sign over there, right? Sometimes when we do transformation by mistake, some additional you can say symbol you will see, and you will predict, okay, it's a minus symbol, right? So those kind of things should not be there. Okay, the price should not be empty. If the product is there, the price should be there, right? Now, when we talk about the store ID should be unique. The store name should not be empty. The location should be a valid location, right? It should not be a hypothetical. It should not be a wrong data, like city is maybe some Indian city and the country is showing as in some other than India, right? So these kind of proper mapping, proper establishment should be there. Okay, when I say the positive value should be there, right? The size is not null. Okay, when I say store size, right, there should be some size. It can't be null, right? So these kind of some values you need to verify. Okay, so basically your test cases should be around all your columns. Okay, and you need to verify. That's it. Now, apart from this, again, you need to segregate your test cases based on these important terminologies, right? First of all, you need to verify the completeness of data, right? So ensure that all the expected data is present in the fact table. When I say expected data, it means it should match with the source records. Okay. This includes verification of all the transactions that have been captured and there are no missing values, right? So when I say all the transactions, you're going to match the count between the source and the dimension tables or the fact tables. Okay. When I say accuracy, right, the data should be accurate. As I said, right, you are having, maybe you are storing the city names with their 3 alphabet character or 3 characters, like let's say maybe for Delhi, it is DEL, right? So this kind of consistency should be there. This kind of data should, this kind of basically the consistency should be there, right? And the data should show proper values, right? When I say Delhi, it should obviously have a country like India, right? So this kind of accuracy or this kind of mapping should be there and should work, right? It should match with the source. When I say aggregation, right, the data by checking that the summary data in the fact table matches with the original data. So when I say aggregation, right, if I wanted to see the total number of customers, the new customers came into the system in last 1 year, okay, and you are getting the result, let's say 4,000 customers, new customers, okay. So this number should match with your source, okay. Now, when I say data types, again, how you are storing your data into the tables. When I say keys, you need to verify the constraints like primary, foreign, and the relationship among them. When I say performance, you should run the queries and see the response, how soon they are running. Okay. What is the time they are taking? Just for, let's always start with the stars. Okay. Like select start from the table and see how much time it is taking to load entire data. Then try and performing more complex operations like joining amongst the tables and see how much time it is taking, right? You should see this performance, and based on the customer expectations, you should flag the, I mean, you can raise your concerns, okay, if you feel like the performance is not up to the mark. When I say data quality, again, the quality standard should be set by the organization, right? It should not contain the duplicate, invalid data or missing data. So if you are storing a phone number, right, it should be having 10 digits or 9 digits or whatever. I mean, based on the standards, okay. When I say transformations, right, you should not see any wrong data or the proper formatting, as I was saying, like the Delhi and something, and the calculated and the derived value. Time period. Since you are capturing the incremental load, you should see the data is updated as soon as it is updated into the source system. Okay. So if the source system received a new file of data, that file, all the transactions should be loaded into the fact table also. So you need to verify this delta record. Delta means the new record or the updated values. When I say scalability, right, it should be your fact table or your dimension table should be created in a way that even if you are receiving a file which has, I'm just giving an example, okay, let's say you are receiving a file which has 3 columns, okay, sales ID, purchase ID, customer name, okay, and somehow you are receiving a new file here which has more columns, okay. So your framework in the ETL should be enough flexible that since you are storing only these 3 columns, not the other 2 columns, while doing the ETL process, it should neglect these 2 columns and only store these 3 columns in the end. Okay. These kind of scalability should be there, or it should be scalable enough to store more and more data. When I say in terms of count, okay, this kind of scalability should be there, right? This kind of transformation should be maintained. So that's all. I mean, these are the major things which you need to verify when you are doing your functional testing or you are doing, sorry, your ETL testing. Okay. So I think that is pretty much okay. And yeah, one more thing apart from this is like you can verify some uh, scenarios in the dimension table as well. like the completeness. You should see the data is completely present in the dimension table, right? So when I say complete, all the customer records are present and they are matching with the source system. Accuracy, again, same thing, right? It should be across. It should be accurate across both the systems, right? Like the source and the dimension system or the target system. When I say data type, again, you have to verify the data types, the keys, the performance. We talked about the hierarchy, basically. That's really important, right? So if there is a hierarchy into the dimension tables, you need to see that hierarchy is present and it is properly maintained. Like you wanted to see the weekly data. Okay. So this week hierarchy should be there in your date table, right? You should see the date dimension table is having the weeks as well, so that you can slice and dice your data based on the weeks. The relationship, again, the relationship among fact and dimension table should be there. The data quality should be matched. The transformation, which we talked about, scalability, right? So the same kind of test cases you need to perform with the dimension table as well, apart from those verification of the columns, right, which we did, right? So I hope this video will helpful for you guys. Okay, if you have any doubt, just feel free to comment in the comment box, and I'll try to respond on them, right? Thank you. Thanks for watching my video. Bye.